Okay, this is a video for the surface area and volume, the first three topics of the unit. And this screenshot is just of the formulas that we wrote the first day that you're going to need to know in order to solve the area problem, surface area problems, and volume actually. So the formulas are straightforward. So the rectangle is base times height. The base and the height have to be perpendicular to one another. Triangle, same thing, base and height divided by 2. Get multiplied together. So the height just needs to be from the tallest point straight down to the base. It's got to be perpendicular. Those two things have to be perpendicular to one another. So if I were to extend this side, it's perpendicular, to the height. Okay, circles pi r squared. Parallelogram, it's base times height, because if I were to take this triangle and move it over here, then this base times this height would make a rectangle. So it's back to the same area of a rectangle right there, base times height. Okay. So parallelograms, base times height, the height must be perpendicular to the base. So this side is not the height. Sorry about this, I forgot to focus it. The height must be perpendicular, so this is our height. And then trapezoid, 1/2 the height, so take half of this number and then times that by the sum of these parallel sides, so B1 and B2. And then if you're not given one of the dimensions, maybe you're not given the height or you're not given the base, you might have to use Pythagorean theorem to solve for an unknown dimension. So for instance, on this problem, if they just gave you the bases, 18 and 12, and then this slanted side is 11, you would have to recognize that the 12 of the units is up to here, so this would be 18 minus 12, so this would be 6 here, and then you would do a squared plus b squared. Remember, a and b are your two sides that are legs of the right triangle, equals c squared, and you would solve for h. Okay, so if I were to solve this, I need to square everything first, so this is 36 and 121, so it's going to be 121 minus 36 to get 36 moved over to this side, and then square root of that. So this height would be about 9.2 units long. Okay. All right, so copy those, and you might have to pause the video, but just copy those notes in if you don't have those already, and move on to the actual work. So for these problems, for the first page, we were just finding the area of each and rounding to the nearest hundredth if it didn't come out. If it came out to a more exact number, or had more digits than the hundredths place. So the first one, what you want to do is you're recognizing which shape it is, so which formula you're going to be using, or combination of shapes. But in this case, this figure is a parallelogram. We talked about what makes it a parallelogram in the previous unit. It's got the parallel opposite sides. So we're looking for the base and the height. So the area of the parallelogram is just BH. So the B in this case is the base side, it's 21. And the H is 33, so that's how tall it is. Sorry, 33. That's how tall it is. So then we would just do 21 times 33, and our answer would be 693. Okay, so a lot of it for the first couple, just recognizing the formulas. Looking at number 4 here, I'm going to let you do 2 and 3. Number 4 is a triangle. We need half, so the area of the triangle, I just write the formula from the formula sheet you copied already. So 1/2 of the base times the height. The base in this case is 27. The height in this case is 16. So typing this in, we can type this in a number of different ways. We can do 1/2 using the fraction symbol. 1/2 times 27 times 16, and get 216. Centimeters squared. Or we could have just done 27 times 16 and divide that by 2. You also get 216. Or you can do 1 divided by 2, that's what the 1/2 means, times 27 times 16, so 216. So a lot of different ways you can plug this in, or you can even use 0.5 for the half, times 27 times 16. So whichever way you prefer, it's going to get you the same answer, but you got options. Okay, for 5, a lot of people may look at this and think, okay, I have no idea what kind of figure this is. But you may have to just turn some things and see if you can recognize. So if you turn it, now it looks like a trapezoid. And again, we did this in Unit 8, where we looked at the different types of four-sided figures. The trapezoid has the parallel sides, so that's what makes it a trapezoid, one set of parallel sides. And these lines are parallel, you can tell. They're running the same direction, they're both vertical. And so our area for that is 1/2 the height times the bases added together. The parentheses means that we need to do that first. So when we're solving PEMDAS, we have to do parentheses, exponents, multiplication and division, whichever they appear first left to right, and then addition and subtraction, whichever appears first left to right. But I would just plug in the height is the distance between the bases. So it doesn't have to be necessarily running vertically. It's just if this was turned on its side, it's how tall it is. So this 32.7 is the height. And then the bases are the 13 and the 38. Okay. So I'm going to choose to use the 0.5 times 32.7 times, and then I'm going to put this in parentheses. So 13 plus 38 goes in the parentheses. So my answer would be 833.85 meters squared. Okay, and it's meters squared because this is a meter unit, and then meters plus meters is also a meter unit, so you have meters times meters, which is meters squared. Okay, then some more like that. For this one, for a semicircle, we don't have a formula for a semicircle, but semicircle just is half of a circle. So we're just going to use the circle formula where it says circle, plug in the circle formula. So we're taking half of the area of the circle. So we do 1/2 pi. The radius is 22, so we do 22 squared. It's 0.5 times pi times 22 squared. So it's 760.27. Okay, in terms of pi, if I didn't multiply the pi part, it would just be 242 pi. So either of those answers is fine. But again, if you times the pi, you get 760.27. Okay, so then those are some other ones are for you to try. I really want you to try these. I'm just going to go through and do a couple of the harder ones. So number 11 is a triangle, so we would use the triangle formula. And you can always pause the video if you need to, if I'm writing this really fast. Just pause it, try to figure it out yourself, and then go back and just replay it if you need to. So area of a triangle is 1/2 base times height. The base here is 26. The height has to be perpendicular to that. So this is actually the height. They didn't give us the dimension for it. So we want to use this triangle here on the right, or the one on the left, they're the same, to solve the dimension that we don't know. So we can tell this part is half of the 26, so this is 13. And we can do the Pythagorean theorem between h, which is the height, 13 and 30. So we have a right triangle with h and 13 and 30. And we've done Pythagorean theorem so much that you should be able to get these pretty quickly by now, but if not, I'll just do it out. The side across from the 90 is always C, so the hypotenuse of the triangle is always alone. All right, so we're going to square 30, so that's 900. And we're going to square 13. And then we subtract the 169 over. And square root that. So h is approximately 27.04. But I want to leave this exactly in my calculator, so I don't want to round anything until the very final answer. So I hope that wasn't muted. So then I'm going to put the 27.04 here. And I'm multiplying that number times 26 times 0.5. Multiplication is commutative. You can do it in any order, and it's still going to give you the same answer. So even if I did 0.5 times 26 times this, it's the same as doing this times 26 times 0.5. So 351.48 centimeters squared would be my answer. Okay, on to the back. There's a challenging one here for you to figure out, but the hint would be, because you need the height here and they don't give it to you, would be to cut it here and find the height. Okay, so that's your hint. For 13 through 18, you're going to be solving using the area formulas to find the missing measure. So what you are doing, they give you each of the figures what they are. You're working backwards to find the missing dimension. So I'll just do number 15. Find the length of the second base if a trapezoid is given. So the area of a trapezoid is going to be 1/2 height base 1 plus base 2. So they give you the dimensions. So they give you the area here is 193.5. The height is 9, and the bases are 29, and then we don't know the second base. We're looking for that. So this is our setup, but you're starting every single one of these problems from 13 through 18 with the area formula for that particular shape. Plugging in what you know. So I plugged in the area, I knew that. I plugged in the height, I knew that, and the base 1. So the only thing I didn't have was B2, so I'm working backwards, basically like algebra, solving for H, or X. Alright, so to get, simplify this, we can do 1/2 of 9, or we can multiply 2 by both sides. So if there's a fraction, we multiply by the reciprocal. But I'm going to just do 1/2 of 9, that's probably faster, and bring everything else down. Okay, so 1/2 of 9 is 4.5. Then I have this times this parentheses, so I can divide, it's multiplied by that, so I divide it out. So 193.5 divided by 4.5 is 43. And then I need to get rid of the 29. It's currently added to B, so I need to subtract this 29 from both sides. So 14 would be my B2. Okay. So every single time start with the formula, plug in what they give you, and work backwards to solve for the missing dimension. So that part is algebra. Okay, 19 is like 11, because all of these are marked the same, so you're going to have to figure out the height because they don't give it to you. But you can find the area of the triangle once you do Pythagorean theorem and find the height. All right. Then on the back, this page you're doing composite area. So the composite area is just a sum of a bunch of other areas. So it's a figure that can be divided into shapes that are basic figures. So it's like a triangle and a rectangle, or trapezoid and a circle. So to find the area of a composite figure, you're going to divide up the regions and then find the area of each. And then once you have those areas, then you're going to sum the areas together. So what that means, for instance, is you want to recognize what figures you have in here. So I'm going to divide this up into a rectangle and a trapezoid. So I'm going to be doing the area of a rectangle plus the area of a trapezoid. And it would be helpful to have the formulas underneath it so you know exactly what you need to plug in. So the rectangle's base and height are going to be 23 by 12. The trapezoid's bases and height, the height is, so the trapezoid's height goes from here to here. If this piece is 12 from here to here, because it's part of the rectangle, and the whole thing is 18, that would make this part 12 minus 18, or 6. And then the bases are these two sides. So the top and the bottom parallel sides are 23 and 15. Right, so then you're just typing all of that in. So 23 times 12 is 276. And then 23 plus 15 times 6, and then divided by 2. And then we're going to add the two numbers together. Okay. So all of these composite areas, you're just figuring out which shapes are there when you divide it up into this different shapes, and then adding the areas of those shapes. Several times you're going to have to find, a couple times you're going to have to find the dimensions, but if you can recognize the shapes that are there, so like this one's a semicircle. But we actually have two semicircles. So we have two area of circles cut in half. So it's semicircles, which means the circle area divided by 2, which really means 2 divided by, the 2's will cancel out, so we just have one full circle. So if we were taking out this middle piece, we just have one full circle, so the area of a circle, plus this shape, which is a parallelogram. Okay. So you're going to be doing the area of a circle and the area of a parallelogram. So the circle's radius is given as 6, and then the base and the height of the parallelogram, so this would be the base of the parallelogram and this would be the height. The 6 is only referring up to here, so then this whole base would be 12. And then the height, again, is just 5. So I'll let you solve the algebra for that, but that's what you're plugging into your calculator. Okay, and there's some more for you to try down here. Number 3 is a little challenging because it's not difficult to recognize the shapes necessarily. So if you take a minute, pause it, and figure out what shapes you have in there, and try to figure out what the dimensions of those shapes are. I'm just going to quickly go through a couple of them. Okay, we have half of a circle, so we have the area of a circle, but we're going to divide it in half. We have a triangle and a rectangle. So the formulas for those, I have them memorized, but you can use the formula sheet for now if you don't have them memorized. You do need to memorize these 3 formulas because they don't give you these on the formula sheet for the geometry OC. Okay, so the radius of the circle, we need to figure that out. So the radius is the segment connecting the middle to the side. Happens to be the same dimension as this rectangle's base, so this is 9. Okay, the triangle's dimensions, we don't have either one of those. But we already found the radius is 9, so that means this radius is also 9. Because the radiuses of the circle are always the same. So the base of the triangle is 9. Now we need to figure out how tall this is. Well, from here to here is 7 feet. Which means from here to here is 7 feet. And this whole thing is 26. From here to here would be how many feet, do you think? It's part of the circle. It's a radius of the circle. Okay, so if you answered 9, that was correct. So 9 would be this piece. So 26 has to be the combination of all 3 of these sections. So we do 26 minus 7 and minus 9. So that's 10 feet is the height of the triangle. Okay, so those are your dimensions that you're doing for number 3. And then you can solve it. I'm not going to do the algebra for you, but the answers, and I will flash the answers so you can just see them. So this is for the first page. This is for the composite figures that we're doing now. So these are the answers for 3 and 4, 2 and 3. Okay, and then 4, the hint is you're going to have to use Pythagorean theorem to find the height. You do need the height for the area of the triangle. Okay, but I'll let you try that. Okay, and then these on the back, this one again, you need to figure out the shape, so I'll let you try that. Shaded region, so if you're finding the area of a shaded region, you're going to find the area of the entire figure, and then just subtract out the unshaded piece. Okay, so in this figure the entire figure would be the square. That includes everything, encompasses everything. So we do the area of a square, which is the same thing as a rectangle. And then we subtract out the circle because the circle part's not shaded. So we want to subtract out the area of the circle. Okay, so this is a square, and I know that because this is a diameter, the 25, and the diameter of the circle doesn't change whether you go that way or you go this way. It's also 25. So these are both the same. And then the radius would be half of the diameter, so it's 12 and a half. So then you're just solving from there. So those are the answers for this part. So I'll let you try these 6 through 9, but that's the gist of this section. You're going to be taking shapes and subtracting out other shapes.